All right, here we go. Notes on 6.3, exponential functions. We are in this unit looking at how do we graph and identify exponentials. To do that, I would like to look at, first of all, remember making tables back in algebra class? We would plug in numbers for x and then figure out y numbers. And so oftentimes we would pick nice easy numbers like -1, 0, and 1. We would look at how the x values are changing. In this case, the x values are going up by 1. And then we can see that the y values are going up by 3. So we can predict that this next value is going to be 9. Two things. Number one, really important that you understand and recognize patterns that happen here. Number two, the x values and the y values have particular names, weird names. So we call the x values the domain values and the y values the range values. And I'll be reminding you of that in this lesson. So that was just something that you learned a few chapters back. So here we go. Here is a pattern that I'm starting off here that is exponential. When I go from 12 to 6 and from 6 to 3, it looks like I'm going down, and it isn't by a specific number. That is, I dropped from 12 to 6, I dropped 6. Here I dropped 3. So instead of thinking of addition or subtraction, we need to think of multiplication or division. In this case, multiplying by a half helps to explain how to get the next number. So what is half of 3? 3 times a half is 3 halves. I know you could say 1.5, but it's probably best to stay in that fractional sense, because in our brain I can take 3 halves times 1 half and then just multiply numerators and denominators, yeah, and get 3 over 4. All right. Before we dive into graphs, just a couple of other reminders, some vocabulary that we're going to be using. Oftentimes we talk about the starting value, and that starting value is referred to as the y-intercept. And then our graphs today are going to come in two different types. Graphs which show growth and graphs which show decay. So I drew a little sketch here of a growth graph and a sketch of a decay graph. The first one we express as a graph that is increasing from left to right, and the decay one would be a decreasing from left to right. So, first of all, here's a table of values. Sometimes they're going to give you that and ask you, is this an exponential function? If it's exponential, what is the growth? Is it growth or decay? And what is the rate? So, if I look at this first table of values, and I could plot them on a graph, but that would take a long time. So instead, remember, we want to look at how are the x values changing. Always start with your domain values, yes? In this case, we see that they're all going up by 1. That's good news. We want that to be always plus 1. If I look at the bottom from 4 to 1, well, I could say I divided by 4th, or divided by 4, or multiplied by a 4th. Or I could see that it goes down by 3 every time. And going down by 3 explains all of them, right? They're all dropping 3 units. 4 minus 3 is 1, 1 minus 3 is -2. Clearly this is an addition and subtraction, so this is not exponential. This is what we would call a linear graph. And because it's linear, we're not really interested in it right now, so we're not going to say anything more about it other than not exponential. Here's the second one. Notice, again, the domain values are all going up by 1. The range values, yeah? The y values, or in this case, we call them f of x. And that's function notation, also something that we learned in the past. Notice it looks like I went up by 4, but if I look at the second one, I would go up by 8. So addition doesn't work. But if I ask myself, what is 8 divided by 4? That's 2. And 16 divided by 8, that's 2. So in essence, I am doubling, or I'm multiplying by 2 each one. So this is exponential. And because it's increasing, this is a growth. And the rate is going to be whatever you're multiplying by down here. Yeah, if this is going up by 1, then the rate is right here. So rate equals 2. All right. Later on, I'm going to actually call that a letter. We're going to say b equals 2. But that's actually tomorrow's lesson, or 6-4. So last thing is, how do I create a graph, right? Some of the problems will say graph the function. Notice it doesn't say y. It says g of x. Again, pretend this is a y. And then here is now an expression. It says 4 times 2 to the x power. Before we proceed, note x is only affecting the base of 2, not the 4. Okay? So again, we'll always evaluate this first and then multiply by 4, following our rule of PEMDAS. So here's a table that I'm going to construct, and then I'll take that information over to the graph. The domain values. You should have 5 domain values in your list, and I would suggest this list of -2 to 2 is a great list to use. Always, if in doubt, use that list. All right, for the first one, -2, that means I need to take 4 times 2 to the -2. For this second one, I'm going to plug in 4 times 2 to the -1, 4 times 2 to the 0, 4 times 2 to the 1, 4 times 2 to the 2. Now I need to evaluate each of these to see what they're equal to figure out the y values, aka, I actually shouldn't put y here, this should be f of x, or no, sorry, not f of x, g of x. So this is going to be my y value. All right, what is 2 to the -2? All right, I'm going to do my work over on the side. 4 times 2 to the -2 is 1/4. So 4 times 1/4 is 1. Again, check that on your calculator. So my first point is -2, 1. Notice we take the x value and the y value and we put it together to get our point. Next, with the -1, 4 times 2 to the -1 is 1/2, right? So that is going to be 4 times 1/2, which is 2. Four times 2 to the 0 is 4 times 1, so that's just 4. And 2 to the first power is 2, so 8. And then the last one is 4 times 4, which is 16. So here we have then our 5 points. All right. Before you draw your graph, note that your y values sometimes get a little crazy. I'm going from 1 to 16, whereas my x values, my domain values, are only -2 to 2. So when I create my graph, I spread the -2 to 2 out, skipping every other one. But my range values, I have to expand, or I have to contract, right? So I'm counting by 2s here, 2, 4, 6, 8, 10, 12. I don't put all the numbers on there because it gets too busy. All right. Graphing now. -2, 1. Get a dot there. -1, go over 1, and then I'm going to go up 2. So right there. 0, 4. So stay 0 on the x-axis, so that means you stay right here, and you go up to 4. Uh, 1, 8, and 2, 16. All right, now we can draw a nice sloping curve through here. And there's my graph. Last part of this problem is, what's the domain and range? What are the domain and range values? Well, remember the domain is the x, the range is the y. Now the domain initially was just these values. But I could have plugged in any values I want for the range. I could have plugged in a half, 0.5, 0.3, -0.3. I could take 300, right? So what we say is the domain is any number. Now the fancy way to say that is all real numbers. Now the range, look at the y values that we have. This is slightly different. Here, it seems I went from 1 to 16. Well, it looks like this is going to get larger and larger, right? This graph is going to go up and up and up. Will it go down and down and down and down? No, I think this graph is kind of leveling out here. I don't think this graph is going to go below the x-axis. How do I know that? I look up here and I see that I don't have any negatives. So this is always going to be a positive number. So my range are only positive real numbers. All right? And there we go. Sometimes it's going to be like all the values, positive numbers bigger than 4, or all the negative numbers, right? So watch out with the range. It's a little bit trickier than the domain. Domain, usually you can plug in any numbers you want with these types of graphs. Best of luck as you work on your lesson 6.3 exponential functions.